What?
Cool.
Oh.
Nope, we are live now. So, hi everyone. My name is Jenny from the Center for Aquatic Sciences at Adventure Aquarium, and we are here to you today for Saturday Species Spotlight, and we're live. So hopefully you guys can hear me and see me just fine, and tap to invite a viewer to be in your broadcast. No thanks, but someone has already popped in. This is awesome. Thanks for joining us. As we wait a little bit, more people hopefully will join in with us as well. So again, my name is Jenny for the Center for Aquatic Sciences, and we are just going to hang out for a couple of seconds, see if more people join in with us. While I'm here in front of you, I want to see if you guys can hear me. So if you can, please type in the comments below. Let me know if you can hear me just fine, or if you can't, we'll figure out how to do with it. Hopefully you guys can see me and all that good stuff too. So if you have any comments, questions, feel free to type them in so we can respond to you. Hi Jim, you've tuned in. Thanks for coming in and viewing us today. So with that, I'm here with, oh good, you can hear me just fine. Thanks Joe, thanks for signing in and saying hello. So with that, again, my name is Jenny, and we are here today with two special friends. I'm going to turn it off to Michelle now, who's going to show you some cool things that we have for Saturday Species Spotlight. Toodaloo.
All right. Hi, everybody. We are so excited today to be here live with you for our Saturday Species Spotlight. Again, I'm a little bit further back than Jenny was, so hopefully everyone can hear me okay. Please comment if you cannot, and I'll talk louder. So I hope you guys have been enjoying this series that we've been doing, and we're excited to bring it to you live today. So again, my name's Michelle. I'm the Public Programs and Animal Care Coordinator here for the Center for Aquatic Sciences at Adventure Aquarium. So we are going to meet a new animal today. Based on some of the fun things on the table, you might have an idea of who it might be. So we're going to go ahead and get started. Jenny, we're good? Everybody can hear us okay? All right.
Looks like we're good.
All right.
So far.
Great. Well, thanks for everyone for joining us. Ooh, 11 people. Ooh, this is exciting. Okay. So we're going to go ahead and get started. So the animal that we are going to talk about today is a horseshoe crab. So this is Harriet, our horseshoe crab. And you guys may have seen an animal like this before, maybe when you've gone to the beach. She's very drippy. Let me move it over. Let me try and move her tank over this way. There we go. So maybe if you've gone to the beach here in New Jersey or anywhere along the East Coast, you may have seen one of these fun creatures. So again, it's a horseshoe crab. Horseshoe crabs are generally found in shallow coastal waters, either in saltwater or brackish water, so like in an estuary or a bay. And they hang out right in the intertidal zone. So that's the area where the waves are crashing, where we like to go swimming. That's where you might find these guys. A lot of times you see them washed up on the beach, and you might see live ones, you might see dead ones, or you might see their molts. They'll actually shed their exoskeleton. We'll talk about that later. So that's where horseshoe crabs can be found. Now, horseshoe crabs, they have a very misleading name. So they're not horses, right? They're not shoes, and they're not even crabs. These guys are actually more closely related to spiders and scorpions than they are to true crabs. So when I flip her over, see if you guys can see that. Whoop. See all those legs? What does she remind you of? That's where you might find these guys. She reminds me of a scorpion. So she has all those legs, actually 5 pairs of walking legs, so 10 total. And she really looks like, kind of resembles her family of that's kind of spiders and scorpions. So what else? So these guys are actually considered living fossils. So they have been around since 400 million years, before the dinosaurs even existed. And their body plan is pretty efficient for survival. So they haven't really changed in that long amount of time. So they have a really nice hard exoskeleton, a nice hard shell. that they use to protect themselves, to keep them safe from predators. They can burrow themselves into the sand and almost appear like a rock, so nothing can hurt them. And they have a kind of a spiky tail here. So horseshoe crabs kind of sometimes I think people kind of mistake these guys for an animal that might be dangerous. So as you can see, she's not hurting me at all. And she is perfectly harmless. So horseshoe crabs cannot hurt you. They can't pinch, even though they have these walking legs that appear like pinchers. They can't sting you, even though they have a spiky tail. And they cannot bite. They don't even have teeth. So they're perfectly harmless. So let's take a look at that tail. So the tail is called a telson. And the tail is quite important to the horseshoe crab. Again, it's not a weapon. They can't sting with it. But see how she's waving it around like that? The way she's waving it around is exactly how she uses it in the wild. So if she were to get flipped upside down by a wave, so a wave comes along and overturns her, excuse me, then she's going to use that tail, she's going to jab it into the sand and fling herself just like she demonstrated there. Good job, Harriet. She's a good performer here. So she's going to fling it upside down and kind of let herself, to right herself in the sand. So that tail is actually very, very important to the horseshoe crab's survival. If they were to lose that tail, they have a less chance of surviving without it. So if you ever see a horseshoe crab on the beach, and it's alive, because sometimes that happens, sometimes they'll come up onto the beach to lay their eggs, which we'll talk about, or sometimes they just get washed up if there's a storm or extra high tide, and they get flipped upside down. And that leaves them vulnerable to predators like shorebirds, and also vulnerable to the heat of the sun. So if you ever see a horseshoe crab like this on the beach, you can actually help that horseshoe crab by flipping it upside down. Now what we want to do is make sure you grab the horseshoe crab gently on either side of its shell or its exoskeleton with 2 hands and flip it over. What you don't want to do is grab it by the tail. And I know it appears kind of scary and you might not want their little legs to touch you, but again, they cannot pinch you, and it's much safer for the crab if you pick them up just like this, kind of like a hamburger. So pick them up on either side and then flip them over and help them get back to the water. You don't want to pick them up by the tail because the tail is actually pretty delicate and could pop off if you grab it that way. So I'm going to slow down and see if we had any questions. Anything we wanted to, or I'll just keep on going.
So we had a comment that said, it seems like these crabs kind of look like spiders. Or that's a comment we get a lot, is that they look like spiders.
They have a very similar kind of the way their legs move, and their body structure is very similar to a spider or a scorpion. So like I said, they're more closely related to them than they are to crustaceans or true crabs. And in fact, horseshoe crabs actually, they have that exoskeleton that covers their whole body, and the exoskeleton will, as they grow, it will shed and they'll get a new one. So like if you've ever had soft-shell crab, that's a crab, like if you've ever eaten soft-shell crab, that's a crab that has molted and they've lost their exoskeleton, and then they're still kind of soft while their new skeleton has hardens. So true crabs actually shed their exoskeleton and back out of their exoskeleton. A horseshoe crab actually crawls forward out of their exoskeleton. So this here I'm holding is actually a molt of a smaller horseshoe crab, and if you can see, there's actually a split in the front. So, ooh, did I just break it? There's a split in the front where the crab crawled out of its exoskeleton. So that a lot of times when you see these on the beach, you're seeing the exoskeletons that they have shed.
All right, great. We have another question coming in from Miss Lori, and she asks, what do they eat?
Hi, Miss Lori. Great question. So I like to think of horseshoe crabs as kind of like the vacuum cleaners of the ocean. So they are bottom dwellers. They will sift through the sand and look for different types of organic matter. They'll look for things that live in the sand, like worms and crabs and little shrimps and things like that, clams. So they'll eat that stuff that's in in the sand, but they'll also eat algae or even anything that might be dead on the bottom of the ocean. They kind of help to clean up anything that settles to the bottom. I mentioned before that they don't have any teeth, though. So how does a horseshoe crab eat a clam with no teeth? So they actually will use those powerful legs underneath to crush their food, and then their mouth is in the center. So their mouth, it almost has like bristle. It's kind of hard to see, but they have like bristle-like.
It's right there in the middle.
They have bristle-like kind of that mouth parts that help them to kind of break their food down even more. But they actually will use their legs to crush harder prey, which is pretty cool.
Awesome. So we have another question coming in from Linda, who asks, does she breathe air?
Ooh, great question, Linda. Thank you. So, no, they don't breathe air, but you did notice I was able to pull her up and down out of the water. You wouldn't do that with a fish, right? Because fish are breathing under the water. She is breathing under the water as well. They do have gills. Their gills are, again, a little bit tricky to see, but their gills are right here on her abdomen, and they are little flaps called book gills. And those book gills actually trap water in between each layer so that these crabs can come up onto the beach and be exposed to air for hours on end, and they're fine because they actually have moisture and water trapped in those book gills that is still keeping oxygen in their blood and keeping them going, keeping them breathing while they're out of the water. So I can lift her up, she's totally fine, she can still breathe, and when she's on the beach laying her eggs, she can still breathe with the water that's trapped in her gills. So she's an intertidal animal. They're really good at kind of doing the going under the water and out exposed to air for short periods of time.
Awesome. So we have a question coming in from Barb, who is asking, how do you know that this one is a she and not a he?
Oh, good question. So the way that we know, so first of all of the horseshoe crabs we have here at the center are female, and you can tell males and females apart by size. So males are generally a little bit smaller than females. This Harriet's actually a small female. Females can get to be about 18 inches, and she's maybe about half that. So she's a small female, but if you look under, not her walking legs, but she has two little appendages in the front that she that are used in mating, and actually for the male. So if it were a male, those two little appendages would look like boxing gloves. And hers do not. Hers are more streamlined, more straight, and she and she uses them to push forward through the sand, whereas the male's boxing glove appendages are actually used to hook onto the female during mating.
Ooh, another question's coming in. Hey, Lori, do they migrate in the winter?
Ooh, that's a really good question. Not that I know of. I believe that they don't necessarily migrate, but when adult horseshoe crabs tend to stay in deeper water, actually, and then when it's time to breed, they'll come closer to shore. So that's why we see a lot more of them in the spring and less of them in the winter. Not necessarily that they're migrating like geographically, but they're kind of just going deeper into the water when it's colder and when it's not breeding time, because they have no need to go to the beach. And then when it's time to breed, that's the only time they really need to be by the beach. So that's when you see them most. So they're going to be breeding in the spring and the summer. And actually the Delaware Bay, so here at the aquarium, we're here on the Delaware River, right? The Delaware River leads out to the Delaware Bay. The Delaware Bay is actually the largest population of horseshoe crabs in the whole world. So if you've gone to the Delaware Bay or any of the beaches around there, we see a lot of horseshoe crabs because we have the largest population, and they are all breeding all kind of together in large aggregations in the spring and summer. Whenever you see a full or a new moon is usually when they're coming up to breed.
Awesome. So we're getting a slew of questions
Yay.
now. And the next one that was on the list is, how many eyes do they have? So number of eyes.
Great question. I was definitely wanting to make sure to cover that. So you can probably see Harriet's two front eyes right up top there, right? So those are her two compound eyes that the horseshoe crabs use to basically find each other, to find mates. They can see images with them, and although they're very sensitive to light. But horseshoe crabs actually have a total of 10 eyes. So they have the two compound eyes on the top. They also have some little eyes, little photoreceptors in the front, some in the middle of their body, and even some on their tail, and even some underneath. So they have 10 eyes total, but 8 of those eyes are very kind of rudimentary eyes that they're using to only see light and dark, basically. So they can, the light sensing eyes can sense the UV light of the sun, and they can also sense the phases of the moon. And so they need that because that's how they will know when it's time to come breed, when it's time to come up onto the beach. They know they have to follow the cycles of the moon.
Awesome. Moving on down the list of questions, we have one coming in from Stephen, who asks, what does he ask? I just saw it. Oh, why are there only females at the center? Female horseshoe crabs.
Good question. We have the horseshoe crabs for educational purposes. So there are education animal ambassadors, and we use them for educational programs, and the females tend to be bigger, so they're a little bit easier to use for programs, especially when you're working with children and they get to see a larger animal. So we generally have only females, and we also are not breeding them, so we wouldn't really need to have males and females at the center.
And in a similar related question, Jim asks, can you have one as a pet?
Great question, Jim. As far as I know, you cannot buy horseshoe crabs in pet stores. So anyone that would maybe have one would maybe be someone who took one from the wild, which we definitely would not recommend. These animals are actually very important to the ecosystem, and we definitely don't want to take wild animals into our homes as pets. They're actually pretty hard to care for as well. You need salt water. Here at the aquarium, we make our own salt water. Our engineers, we pump in fresh water and clean it up, and then we put salt water in, and it's a big, complicated process, not something that you would really want to do in your house. And they have very specialized food sources as well, so they're not really an ideal for a pet. Great question.
Our next question comes in from Peter, who asks, are there any predators for the horseshoe crabs?
Oh, good question. So yes, so horseshoe crabs are actually most vulnerable when they are small or when they're eggs. So horseshoe crabs, one female horseshoe crab can actually lay 90,000 eggs at one time. And when they do that, they come up onto the beach to lay the eggs. Can you get me my birdie? It fell down. And one of the big, predators of the horseshoe crab eggs is a bird called the red knot. This is a shorebird. But this is a very, very important process. So the horseshoe crabs, the birds, actually time their migration with the breeding of the horseshoe crabs. So the red knots will all end up on the beach at the same time as the horseshoe crabs are laying their eggs, and that's why the horseshoe crabs lay so many, because they have some to spare for the birds, and then others will survive into adult crabs eventually. So they do, and the little birds, they actually use this area as kind of like a gas station to fuel up in the middle of their migration, and they'll double in weight on just feeding on horseshoe crab eggs. And this bird, the red knot, is actually an endangered species. So the horseshoe crabs are helping to support that species' survival. Once they get larger, though, predators might be something like sharks or maybe even sea turtles. Sea turtles have those strong beaks, and they can crush down on the shells of the horseshoe crabs. And then definitely when a horseshoe crab, if it gets stuck up on the beach, then shorebirds like seagulls might actually try to go after their body parts that are inside their shell.
Cool. Pardon me. So we have a couple of folks who joined us a little later, so I thought we could review some of the things we already said. The
Sure.
two repeat questions that are coming up is, again, what do they eat, and can you pick it up by the tail?
Okay, so thanks for joining us, everyone, and welcome those of you who just joined. So first of all, again, what do they eat? So horseshoe crabs are bottom feeders, so they are going to feed on anything that you can really think of that might live in the sand or in the mud. So they might eat snails and clams, worms, algae. They are really, I like to think of them as kind of like vacuum cleaners of the ocean, because they're just going along and just picking up anything that might be in the sand, especially anything that might be dead. So if something, if an animal dies and is sitting on the bottom of the ocean, a horseshoe crab is one of those kind of scavengers that will help to clean up that mess. So that's basically what they eat. And can you pick it up by the tail? It's definitely not a good idea to do that because it's not safe for the horseshoe crab. So the tail cannot hurt you. It's not going to sting. It's just it's a pointy tail that they use to flip themselves. If they get flipped upside down on the beach, they will use their tail to right themselves. They'll stick it into the sand just like she's doing now, and kind of like a catapult, it'll flip her back over, right? Now, so she needs that tail. It's very important. So if you were to pick one up, we recommend picking it up just like kind of like holding a hamburger, 2 hands on each side of the shell, very gently. Their legs will touch you, I guarantee it, but they will not pinch you. They cannot pinch you. So just be prepared for that it feels a little funny, right? They look a little creepy, they feel a little funny, but they cannot hurt you. But their tail is very delicate, so you don't want to pick them up by the tail.
So we have a special request from Miss Mallory all the way out in North Dakota.
Hi,
saying
Mallory. Hi. Special request.
That was one of her questions, was the, not the tail one, the eating of the food.
Okay.
Question. So that was Mallory's question. So we have another question that I kind of skipped over that I missed by accident from Mr. Jack, who asks, how long can the horseshoe crab stay out of water?
Oh, all right. Thanks, Jack. So the horseshoe crabs, they can be out of water for a couple hours at a time. We talked a little bit about their gills and how their gills work. So their gills are kind of like pages in a book. They're called book gills, and they can actually trap water in their gills so that they can come up onto the beach to lay their eggs, and they can be out of water for hours at a time as long as they're not too exposed to wind and too much sunlight. But that's why, in order to, during breeding time, they will come up at night so that they're not too dried out too quickly by the heat of the sun and that hot sand that you would experience during the day. So they wait till nighttime to come out. But they can definitely, they're an intertidal animal, so they can be exposed to air for a few hours, usually around the flux of the tides of low and high tide.
Awesome. So we're getting close to end of time, but there are 2 great questions and comments that have come through that are kind of related. So the first is, what color blood do they have? And the second is, Stephen heard that they're kind of important to the pharmaceutical industry, and why is that?
Great questions. That's actually what I definitely wanted to make sure to cover that, so thanks, guys. So horseshoe crabs, we talked about why they're important to the ecology. So their eggs are really important food source for birds. They're considered a keystone species in the environment because without the horseshoe crab, other animals would suffer. So the horseshoe crabs are a keystone species ecologically, but they're actually important to humans too. So horseshoe crabs actually have blue blood. So our blood is red and it's iron-based. Their blood is copper-based, so it's actually blue. And there is a chemical, kind of a compound in their blood that can detect bacteria and other toxins, which has helped these guys survive for millions and millions of years. That same compound, scientists have figured out that they can use that compound to test medical equipment for humans. So if you've ever had a flu shot, if you've ever had any kind of injectable vaccine, if you've had a knee replacement or a hip replacement or any kind of joint or any kind of thing that's surgically inserted, that medical equipment is actually tested with horseshoe crab, with a compound made from horseshoe crab blood. And it doesn't hurt the horseshoe crab to access their blood, so just like when you go to donate blood, it's kind of the same idea. They can actually harvest the horseshoe crab or get the horseshoe crab, and they can take a little bit of the blood and then put the horseshoe crab back into the ocean, and then they use that blood to make that compound that they test every single needle and every single surgical implant that we have. So basically, if you've ever had any of those things done, you can thank a horseshoe crab for keeping you safe and keeping that bacteria away from you. Yeah. All right, so we're going to be here for a few more minutes. We're going to go ahead and wrap up, but afterwards, if you want to stay on Facebook and ask us more questions, please feel free to do so. I'm so happy you guys joined us. I hope you had fun. I hope you learned something. And coming up on Tuesday is Giving Tuesday, so if you've enjoyed these types of programs and you want to see more from the Center for Aquatic Sciences, please consider donating and supporting us, the Center for Aquatic Sciences at Adventure Aquarium. You can do so on our website. And join us again next week for another Saturday Species Spotlight at 1 o'clock, and we're going to be live again. So this was really fun. I hope you guys enjoyed it. And Harriet says goodbye.
Bye, guys.
Bye, guys. Thank